Okay, this is assignment B of hypothesis testing. This is unit 9. Um, so again, I'll try to briefly kind of walk through what you should be doing. Again, to get correct answers, again, there's very little math in here. It's just knowing how to write. Okay, write your answers. All right, so what we look for originally is the mu, and that's what the historically showing should be the average. And that's usually how they start. So a machine in the student lounge dispenses coffee. An average cup of coffee is supposed to contain 7.0. So historically, the average should be 7. Okay? Now, from there, we want to take a sample average. So there's going to be a second average given to you or easily obtained in the problem that, okay, so historically showing it should be 7. However, I just looked at, some cups of coffee, and I noticed that their average of my sample is 7.3. All right, so what this process is saying, hey, there might be something wrong with our idea that the average is 7. It might be more, it might be less, it might be different, something, but something is wrong with the average, potentially. Okay, we have a standard deviation. Notice how this one is a sigma of 0.5. We need a sample size. So how many cups of coffee did we look at? And we looked at 8 cups of coffee. And then we have this like fish symbol, which is our level of significance, and that is going to be 5%. Okay. Very first question wants our null and alternate hypothesis with the level of significance and the type of tail, left, right, or 2. All right, and so what the null hypothesis is, it's H naught. That's the null hypothesis. And that is what the historical average is right now. So it's 7. And then your alternate hypothesis is pretty much the same symbol and same number, but you need to decide what symbol goes in there. Is the average bigger than, less than, or not equal to? And that's usually coming from the question itself. Okay? A lot of times it'll ask, hey, is the average now more than 7? Or is it less than 7? Is it different from 7? Something like that. And I see that it is different from 7 ounces. So that doesn't necessarily mean that we want our average to be bigger or smaller, but rather not equal to. It's different. It could be bigger, it could be smaller, but as long as it's quote unquote different. So that means is not equal to. All right, the level of significance is your alpha. In this case, that's 5%, which is 0.05 written as a decimal. And usually what I said is like if the inequality, the alligator, is pointing to the right, it's a right tail. To the left, it's a left tail. Well, this one, it isn't an arrow, so this is the 2 tail. Some of the stuff down here. Okay, the next question is what type of sampling statistic are you using? Is it a standard normal or a student's t? Because we have a sigma, okay, sigmas and probabilities, we're going to be using a z, which is a standard normal. If you are given a standard deviation that is an S, then you're going to be getting a t, which is a student's t. All right, so this one is a standard normal. And so z, because of this, is x bar minus mu of sigma divided by the root of n. It's all good as long as you keep the numerator and denominator in their own unique parentheses. This will work out just fine. So I go with x bar minus mu divided by sigma divided by the root of n. So again, just make sure your numerator and denominator are in their own unique parentheses. This is a z-score, so I take this to 2 decimal places. Okay, next we find this p-value. The p-value is based upon the answer that you just got. So we have a z of 1.70. Recall that we always look that up as a negative number. So let's go to my z table, our z table, and look up 1.70. But again, look it up as a negative. So negative 1.70, 0.446. Now, this is a very unique problem. Usually that is the p-value and we can move forward from there. This is unique because this is a two-tail with a z-score. And then this very specific. It has to be a two-tail with a z. And when it's a two-tail with a z, we multiply this p-value by 2. It's a very unique, it's probably not going to be this way on the test, but I got to give you the heads up. We multiply this by 2 due to this is a two-tail. So the p-value is actually, in this situation, 0.892. Again, this is only with a z with a two-tail. Not a t with a two-tail, a z with a two-tail. So 0.892 is the actual p-value of this problem. All right, how do you draw a two-tail? So if it's a right tail, the rejection zone is on the right. If it's a left tail, the rejection zone is on the left. A two-tail indicates that there is a rejection zone on both sides. That's the rejection zone, and then do not reject H naught is in the middle. These are alphas, which are 5%. Okay. Now, where the heck does this p-value go? The p-value, again, think of this kind of like as a distance from the edge. The distance to this point from the edge is 0.05. That's the distance to that alpha. So where does the p-value fall? Is it bigger than, is the distance larger than, or smaller than that 0.5? And this one is 0.8. So it falls out here somewhere. This is my 0.8. The distance is longer. So this p-value, I put it as like a little dashed line, and I recorded p-value is 0.892. All right, so what did I just show? I just showed that the p-value is greater than my alpha. What does that mean? That means I do not reject H naught. I do not reject H naught. All right. So up above, you'll notice that the H naught was mu is equal to 7.0, and H1 mu was not equal to 7.0. All right, so if I have to write a conclusion, okay, and this is my answer, the words that I say, I'll just kind of type it here. All right, so this is what we say. We do not have enough evidence to say H1. We do not have enough evidence to say H1. This is what we're going to say. Let me write this in green so we don't get it confused with other stuff. Let's go back green. All right. All right, here we go. So when that's our answer, this is what we say. We do not have enough evidence to say H1. But not actually say H1. We interpret the symbols of H1. Okay, so here we go. Okay, so we do not have enough evidence to say H1. So that is the average. So in context, we're talking about coffee dispensed. So the average, okay, so that's that symbol. That middle symbol is not equal to. That's the middle symbol, and then 7.0 ounces. We do not have enough evidence to say that the average amount of coffee dispensed is not equal to 7.0 ounces. So that's in essence saying we do not have enough evidence to say H1. So the new part to this one is multiplying the p-value by 2 because this is a two-tail with a z. This is a very, very unique situation. You don't see this one very often. But when it's a two-tail with a z, you multiply the p-value by 2. Okay, so again, in this problem, we're looking for something that is different. So this, again, is going to be a two-tail as well. It's going to be a two-tail because the question is it different from? They have to very specifically, this is the determining factor of your, if you're looking for an average that is greater or is less than, it's the question itself that determines what you're trying to do. All right, so here we go. So historically showing the average height of hockey players is 71 inches. However, we took a sample, and our sample had hockey players at a height of 72.5. All right, we have a standard deviation of 285, a sample size of 14 hockey players, and we want a level of significance of 5%. So we begin with our null hypothesis, and that's what the average is. So the average is 71 inches. Our alternate hypothesis is the same symbol and number. However, what is the question asking? And the question is asking, is it different from 71? So that means I don't care if it's bigger, I don't care if it's smaller, as long as it's not equal to. All right, so the level of significance in this case is 5%, so I write that down, and that is 0.05, and this is a two-tail in that regard. Again, we don't see these very often. All right, because this has a sigma, that means that we're going to be working towards a z. So that's going to be a standard normal. And so the z in this situation is x bar minus mu, sigma divided by the root of n. Recall that you put a parentheses around the numerator and the denominator. So we go x bar minus mu divided by sigma divided by the square root of n. At 1.97. From here, I turn this into a p-value. So the p-value in this situation is built upon a z-score of 1.97. Again, we always look that up as a negative. What does he do? 1.97. So negative 1.97 is 0.244. Now, because this is a z with a two-tail, this is times 2. So times 2, because this is a two-tail. So 488. Okay, time for the picture. This is a two-tail, so the rejection zone is on both sides. And that edge is alpha. This middle clean area is the do not reject zone. So we have the rejection zone and the do not reject zone. Okay, our value of our p-value is 0.04. So again, think of this as a distance from the edge. If this is 0.05, our p-value is 0.04, which is shorter. 0.04 is smaller than 0.05. So our p-value stops about right there. And it falls within that rejection zone. So what am I seeing as a result? I'm seeing my p-value is less than my alpha, thus reject H naught, except H1. Real quickly, the above, again, the null hypothesis was that the average is equal to 71. And the alternate is the average is not equal to 71. So when I have the result that is reject H naught, accept H1, that is exactly what we say. Okay, all we do is interpret symbols. We reject the average and use context. Middle symbol is equal to. (71 inches). Okay, so we reject H naught and accept the average. I already used the context, so I don't have to describe, this is hockey players or something. Again, just as long as you say it once. Middle symbol is not equal to. And 71. We reject that the average height of hockey players is equal to 71 inches and accept that the average is not equal to 71 inches. So again, that's how you say reject H naught, accept H1. You literally just say reject average is equal to 71, except average is not equal to 71, or whatever your null and alternate hypothesis is. When you have that problem where you do not reject H naught, you say we do not have enough evidence to say H1, and again, you just go the average is not equal to 7.0. So it's just interpreting symbols. Don't put your own words in there.